Okay, Assalamualaikum and a very good day. My name is Wan Muhammad Azam bin Wan Harun, number metric DE190031, and today I want to present about introduction. Okay, in the computer and software engineering, execution is the process through which a computer or virtual machine interpret and carries out the program instruction. Each program instruction is this description of the specific action that must be executed to solve the particular issue. Execution include repeating the fact the code execute cycle for each instruction as the execution machine execute the instruction in line with their semantic. Certain results are created. A user can enter command into the interpreter's interactive session, or computer program can be executed in batch mode without user input. The command is in this situation are just interconnected software instruction. The basic computer concept we use, which is Mary, machine architecture that is really intuitive and easy. Provide a set of simulator for the machine written in Java. The literature review, Mary is fundamental CPU simulator that implement the von Neumann architecture. It is installable and used online. This project utilities the Mary online simulator located at https://maryjs.org. For the machine, the publisher provide a set of Java-based simulators. A binary-based assembly language is a low-level programming language. Each binary number refer to a command. There are many registers in Mary. Example include accumulator (AC), program counter (PC), memory address register (MAR), memory buffer register (MBR), and instruction register (IR). A subroutine is a series of instruction that is modular and may be executed several times. The address of the instruction that will be performed after the JNS instruction has been executed keep in the JNS instruction. When the required task has been complete by the subroutine and jump instruction is executed, the PC register will be loaded with the memory location provided in the print variable X label.
Ya, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Safi Ibn Muhammad Saleh. My metric number is DE190048. So today I'll be presenting the simulation for Mary for my group project task. So here I am coding. So basically from this coding, I just solve a simple equation which involve add and subtract. So my equation is W is equal to X plus Y minus Z. So here I declare the value for x, y, and z. So x is 15, y is 30, and z is 30. So in conclusion, my equation is just solving 15 plus 30 and minus 7. Okay, so we will look at the Mary symbol. Okay, so the operation for the RTL log will all be in hexadecimal value. So here I just adjust to decimal just to get the value from our equation, which is in decimal. So here we will go one by one. Okay, so first we'll go to load, and this is the RTL log for the load. Next is the RTL log for the additional y, and for subtract z. Then this is for the output. and this is halt, which and this is for output, and then this is the halt, which will stop the program. Okay, so next we will view the data path. So here the data path function is to give us a clear view how the code will uh, go through the data path of the program of our program, which is same as earlier without dialogues, but this will give us a clear way path so we can identify it. So assemble next. So this is from load. So from the IR register, which all this will be in hexadecimal. So 1006, and then next it will go to the MAR memory address register 006, next to the MBR, which is memory bus register, which is 000F, and then it will move to the accumulator. Also the same for additional Y. So in the IR is 3007 instruction register, then MAR value is 007, next MBR is 001E, then it will go to the accumulator, and then next we will move on to the next operation, which subtracts Z. So here the IR value is 4008, and the MAR value is 008, and then MBR value is 0007, and it will go to the accumulator. So the value in the accumulator will be 0026. So the equation will be finished, and then it will be stored in W. So here show from IR 2009, and then we will go to the MAR, which is 009, next to the MBR is 0026, and then it will go to the, and then for the output. So from the store in W, it will go from the accumulator to the output. Then next halt, it will stop the program or the Mary architecture from working. So it is finished the architecture data path flow. So that is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Gladys Nanazar binti Zahirisan and my metric number is CE190061. It is the methodology of this project. In this project, students should use a simulation tool to explore the concept of computer architecture and organization as part of a group project assignment. We decide to use Mary's online simulation tool for this project simulation. Each machine architecture has its own set of assembly language. x86, ARM, and IPS are all fairly complicated architecture. x86 even more so than ARM and MIPS, which is why Mary is designed to be simple to understand, hence its name. The name suggests it stores the current position of the instruction. Use the Mary simulation tool to simulate the basic computing concepts in this project. Okay, that's it. So I will pass to the next member. Thank you.
For the conclusion, in this project we are able to illustrate the basic computer concept, which is in Mary. Mary stands for machine design that is really intuitive and easy, and it is a basic architecture made up of a memory for storing program and data, and the CPU consisting of the ALU and several registers. With some research for this software, we had know how to use Mary online simulation tool for this project simulation. In Mary, we also know there are 7 registers, which is the accumulator is a device that store data values. This is a general purpose register that store information from the CPU to process. The memory address register contain the memory address and the data being referred to the memory buffer register, which store either data that has just been read for memory or data that is about to be written to memory. The program counter will store the location of the next instruction in the program to be performed. The instruction register is where the next instruction to be executed is stored. The input register store data from the input device, and output register store data from the output device. In Mary, we also learn that multiplication entails writing code for the addition of two integers, particularly for a negative numbers. There is no multiplication instruction set for Mary, as Mary sim is only capable of subtracting. Instead, we may conduct iterative addition using the combination of add and sub instruction, and then terminate the program after evaluating the result. Multiplication is most easily accomplished using iterative addition. For instance, the expression 3 star 4 may be expressed as 3 multiplied by itself for 4 times. This is equivalent to adding 4 to itself 3 times, since multiplication is commutative. The order in which integers are multiplied in is irrelevant. We also know that Mary does not applicable to their programming, since implementing if an else statement is quite hard and require numerous instructions. We instead utility skipcon. If the specified condition is met, skip the next line, which is explained in the Mary instruction set section. However, we can conclude that because using simulator can challenging, they has create a website version that student can access is it readily and easily. I think that's all from us. Thank you.